notations and functions. We did some of this lesson last class, as you recall. I'm still going to reteach that stuff just to make sure we're good on it. But the big thing for today is domain and range. So domain and range, domain's the x values, okay, and range is going to be the y values. So whenever we talk about domain and range, domain is how far left to right. So I'm going to write left to right here. And then range is bottom to top. All right, and you're going to have to actually write all your answers in interval notation today. So if we look at this graph right here, the first one, I just like to start off with a basic domain and range problem. This thing goes forever in the left direction and forever in the right direction. All right, so we're going to say the domain of this function is negative infinity to infinity, or you could just type in the all real numbers button. Okay, the range is going to be from the bottom to the top. So the lowest this graph goes on the y-axis, because it's the y values, and we'll get the y-axis, is 0. I need to include 0, so I have to use a bracket, because that's a point there. And then it goes all the way up forever, because those arrows are going forever. So that would be to infinity, because it's positive infinity, because I'm going up. All right, if I give you a circle, okay, domain of a circle, all right, how far left does this go? Well, it goes to -1. How far right does it go? Well, it goes to 5. And again, those are closed circles, those are points, so I have to use a bracket to include them. Range is bottom to top, so I go on the y-axis, bottom to top. So that's -3 to 3. And again, I have to use brackets because those are closed circles. All right. Also, they're going to ask you on the Hawks whether it's a function or not. So to determine whether it's a function or not, you do the vertical line test. So if I draw a vertical line, it should only hit the graph thing once. So this one would not pass the vertical line test, because it hits it twice. And so what you're going to have to do is you're going to have to come up with 2 points that prove it. So whenever you draw a vertical line, just draw a vertical line through that function, and then find the 2 points that prove it's not a function. So as an example, this one would be 2, 3, and 2, -3. And again, these are points, so they're going to be parentheses. Now the reason why this proves it's not a function is because x repeats. I don't know if you guys recall from Algebra 2 or even Algebra 1 that x can't repeat in order to be a function. So that proves it's not a function because your x value repeats. All right. This one over here, if I do the vertical line test, every vertical line I draw only hits the line once. So that means it passes the vertical line test, which means it's a function. So that's kind of the basis of what we're doing today. So again, I'll give you a graph. I'll say, hey, domain and range, and then is it a function? So this first one, domain, range. Okay, sometimes domain can be literally just a number. So on this one, the x values, domain, it doesn't go anywhere left, it doesn't go anywhere right, except for the only numerical value is 8. So the domain is literally just the number 8. The range is from bottom to top, so I would go my y-axis, it goes down forever, goes up forever, so that would be negative infinity to infinity, or again, you could use the all real numbers button. Completely up to you on that one. The next one, a flat line, domain and range. Okay, domain was how far left to how far right. Okay, this one goes on forever, so negative infinity to infinity, or I could say all real numbers. The range on the y-axis is just one number again, so again, I can just have a single number as my domain or my range. So then they're going to ask, is it a function? Well, if I draw a vertical line here, that hits it at every single point. So that means it's not a function because it fails the vertical line test. It hits it more than once. This one, if I draw a vertical line, okay, it only hits the horizontal line one time, so that means it's a function. Now again, you're going to have to provide 2 points to prove it's not a function. On this case, it's going to be anything like 8.2, 8.1, anything with a repeating x value proves it's not a function. So that's my 2 points that prove it's not a function. So you do the same thing here, domain and range. Okay, x squared minus 2x minus 3. Whenever I do this, domain is going to be negative infinity to infinity, and range is going to be -4 all the way to positive infinity because it's going up forever. So that's my range, that's my domain. This one right here, if it's a linear function, your domain and range are going to be all real numbers, or negative infinity to infinity, however you want to write it. Okay, because it goes forever on the left, forever on the right, and it goes forever down and forever up. So then I kind of just want to go over some basic parent functions to whenever we're doing this. So whenever you have these functions, it just says, hey, to determine the domain and range of each function, determine if the function is, or the ratio is a function. So the ones that I really want to focus on that you're going to see a lot, especially when it comes to domain and range, are square root of x and 1 over x. All right, so that would be these two right here, the general rule of those. Now, whenever you're doing this, whatever it may be, okay? So square root of x, the parent function starts at 0 and it makes like that curved line, however you want to describe that. But realize, whenever you're doing this, you can't have a negative number inside a square root. Like, that's an imaginary number, right? So we're going to talk about how to approach the domain of this one. If you have a fraction, okay, whenever you're doing these, just realize, what's the one value I can't have on the bottom of a fraction? Well, that should be 0. So we're going to set the bottom equal to 0, and then we're going to talk about how to approach those, okay? So before I get into like the stuff that's really, really important with that domain and range, they do have this question on there about domain and range, and they give you this big long thing. And so it says x, y, such that x belongs to integers and y belongs to x. Well, whenever you see this, remember, domain is the x values, range is the y values. So in this case, they're going to give you multiple choice. My domain is going to be that integers button, that z. My range in this case is the y value. But notice they say y equals x. Well, what did x equal? X belonged to integers, so it's also going to be a integer. So if it's y equals x, you're just repeating what x was, aka the domain. Sometimes they'll have different values here. So in this case, my domain on the second one, it says x belongs to z, so that'd be integers, and y belongs to n, so that'd be natural numbers, right? It's okay to have different numbers, but if it says y equals x, then you're just going to use whatever x was, whatever it belonged to. Okay? So domain and range. The big things, like I said, that I want to focus on are these ones. I also want you to focus on the domain of a parabola. We'll do more in-depth stuff with this later on in this unit, but this is kind of like the intro to it. If you see x squared, realize that's a parabola. A parabola, the domain is always going to be all real numbers. It goes on forever left and forever right. So if you see an x squared anywhere in the function, just know that your domain is going to be all real numbers. It has to be, okay? Just because a parabola is going to go forever left and forever right, just the way it works. We'll talk about these square roots and these 1 over x plus 1s. All right, so it says determine the implied domain of the following function. So here's where it gets a little complicated. If you see a fraction one, if they give you a function like this, again, when we're doing domain, we're focusing on the x values. So when we do domain of this one, we're going to focus on the x values, more specifically the bottom of the fraction. So I'm going to set this bottom equal to 0, and I'm going to say that's the one value it can't be. So I'm going to add 12 over. The one value x can't be is 12. Well, if I can use any number I want on the number line except for 12, it's really just an open circle and you're shaded forever that way and forever that way. Well, the way we write that, we would say it's negative infinity to 12 with a parenthesis, union, 12 to infinity. It's like we're skipping 12 because we can't use 12. That's the only number we can't use. So then the same thing, like try this one before I talk about it. You can pause the video, but like this one, right? It's still a fraction. I focus on the bottom for the domain. I say it equals 0, and I said it can't be this value. So I'm going to subtract 2. That means it can't be negative 2. So if it can't be negative 2, I'm going to say negative 2 to infinity, and then negative infinity to negative 2 with a union in between them. Okay? Next one. This is probably the toughest question if you ask me. They put a square root on the bottom. All right, a square root function, we know we can't have a negative number in there. Okay, so we're going to say, hey, this has to be greater than or equal to 0. So we're going to take inside the square root, and we would say it's greater than or equal to 0 typically. However, you can't have 0 on the bottom of the fraction, so I'm going to say it's just greater than 0. So I'm going to subtract 2. It has to be greater than negative 2, so I graph it on a number line. Negative 2, open, shade that way. So my domain is negative 2 to infinity with a parenthesis. And the reason why is if I plug in negative 2, I get 0. Can you have 0 on the bottom of the fraction? No. So normally we would say it's greater than or equal to 0, but because it's on the bottom of the fraction, it's just greater than. So same way here. This one, again, you would try it before I hopefully go over this. I would say x minus 4 is greater than 0. You add 4. Has to be greater than 4, so I would make a number line, open circle, shade to the right. So I would say 4 to infinity is my domain. So then if I just give you a square root and no fraction, okay, like these, you only focus on what's inside of the square root. We do not care about anything that's outside the square root. Now, normally we would say it's greater than or equal to 0 because you can have 0, you just can't have a negative number. So I would subtract 9, x is greater than or equal to negative 9. I would say it's negative 9 to infinity because whenever you graph on a number line, negative 9, close, greater than or equal to, I would change to the right. So same way here, Okay, because there is no fraction, I just focus on what's inside of it, and this time it's greater than or equal to 0. If there was a fraction and it's on the bottom of the fraction, right, it's just greater than. So I would say greater than or equal to 0. All right, I added 5. I make my number line. You get 5 to infinity. Okay, you guys kind of get the point of that, hopefully, whenever it comes to domain. So again, I just do a whole bunch of examples. So this one, same thing. I take inside of it. Okay, say it's greater than or equal to 0. Now this one's a little bit difficult because what happens to your inequality sign if you divide by a negative? Right, you have to flip it. So don't forget about that. You need to flip it. I would do negative 18, but now I want less than. So I would say negative infinity to negative 18 with a bracket. Just make sure that you know if you divide by a negative, okay, so it's still always greater than or equal to 0. If I divide by a negative, you have to flip your inequality sign. Okay, so that would be less than or equal to 7. So I do 7, close circle, less than or equal to. So that would be negative infinity to 7. Also in this thing, you're going to have to rewrite a function of x. So rewrite the relation as a function of x. This is the fancy wording. All it means is solve for y. So you're just going to take your function, you're going to solve it for y. All right, so they're going to talk about this. You would solve for y, I'd add 6x, add 6x, add 3y, add 3y. I get 2y equals 9x. Divide by 2. I get y equals 9 over 2x. So that's what you would type in, and you're really just typing in that part. And then it says in step 2, you're going to plug in 2. So I'd plug in 2, solve it. When you do that, so f of 2, plug in 2, I solve it. I end up with 9. That's what you would type in that box. So then the third question is going to ask about the domain. Well, you just got to know, what kind of function is this? Is this a linear function? A linear function, the domain is always going to be all real numbers. Okay, because like you think about a linear function, it's going to be a straight line that goes forever, right? It's always going to be all real numbers. Now the next one's a little bit more difficult because again, we're still solving for y, so like I'm going to make this one a little bit easier. I'm going to add 5y over there. I'm going to divide everything by 9, and you could type it in like this, negative 6x squared minus 4x over 9. Okay, so that's what I would type in. And so whenever you do that, it's going to say, okay, hey, plug in f of 2, you plug in f of 2, you solve it. I'm not going to do that on this one, but it's going to ask for the domain. The key part here, it has an x squared. I told you earlier in this thing, if you see x squared, that's a parabola. We have to know the domain of a parabola is going to be all real numbers. Okay, so if you get a linear function or a parabola, you know your domain is going to be all real numbers. So that's going to be the third step in that. Here's what we did in class. This was the tough stuff. I'm only going to do one of each just so you have an example. So as a reminder, we're doing one part at a time. So this one, I'm plugging in x plus a. So I'm going to take it. I'm going to plug in x plus a for every x. Okay, and I'm done with that one. So then we're going to do the yellow one. Minus the original function. So I would say minus in parentheses because you're going to end up changing the signs. All right, so then you get the FOIL here. So I end up with this whenever I FOIL. I fully expect you guys to FOIL that. And then I'm going to distribute that. Distribute my negative. And I distribute my 4 into all this and rewrite it again. So you guys get the point here. It's a lot of work. I understand that. But just make sure, as long as you get it set up right, I firmly believe you guys have the mathematical capability to solve those from there. So then you just combine like terms. X squareds cancel. Okay. X's cancel. And then all I have left is 4xa, which is 8xa. I have an a squared, which should have been 4a squared. That's multiplied by 4. And then I have a minus 6a. I know it's easy to make a mistake, but make sure you're double checking your work on those. So same thing here, right? It's the same type of problem. They're going to take this function. I'm going to plug in x plus h. So I'm going to do 3x plus h minus 2. And I'm going to say, okay, minus. Now we're going to do the next part, f of x. So that just means I'm going to put minus, parentheses, 3x minus 2. I just read the function, and it's still all over h. This one's a little bit easier because you don't have to FOIL. So I get 3x plus 3h minus 2 minus 3x plus 2 all over h. I combine my like terms. Negative 2 cancels. 3x, negative 3x cancels, so I get 3h over h. Well, I could take away an h there. I get 3 as my answer. So that one's a little bit easier, but again, make sure you're distributing that negative sign to the last part whenever you plug in the original function. And then here's the one that I think is the hardest of the whole Hawks whenever you're plugging this in. So it's the same type of thing, plug in x plus h. So I plug in x plus h for every single x. All right, so I write the function, then I do minus, right? We're going to distribute that minus sign to the original function, so I'm going to write it again. And then we know at the end it's all over h. So I'm going to FOIL here, so I end up with this when I FOIL.